Okay, so what do you think the analogy is going to be in 4D?
Well,
What ratio are we going to be looking for?
probably the hypervolume.
Okay, which I'll just call volume. I'll put it in quotes. The volume to what?
To the surface volume.
Right, to the surface volume, which I'll just call... Yeah, actually surface volume is probably a pretty good idea. So hypervolume to surface volume. Good. So in order to do this, and then we have to... In the other analogies for circles and spheres, we ended up with some constant times pi.
Mm-hmm.
Okay, so now we just have to learn
What the hypervolume formulas are.
for a sphere. So for a hypersphere, the volume is 1/2 pi squared radius to the 4th. What? So what's surprising about that?
Well, we had radius cubed last time.
Yeah?
And then we had 4/3. But we only have pi squared.
Yeah. So the radius of the 4th isn't a big surprise because we've had...
Third, second.
Yeah, so
Fourth.
that's not too surprising. But the pi squared is a big surprise. The surface volume, as you called it, turns out to be 2 pi squared r cubed. So we have a weird and unexpected problem in 4 dimensions. We end up with a pi squared rather than a pi to the first power.
Yeah.
So what do you think we're going to be able to solve for here?
Probably pi squared.
Okay, and then how will we find what pi is?
Take the square root of whatever we get.
Take the square root of whatever we get. Okay,
Well,
so what do you think we're going to need to do here?
I take this whole thing to the 3rd power and this thing to the 4th power.
Okay, so that's going to give us, maybe I can write over here.
It's going to give us,
So on the top we're going to get this to the 4th power, you said?
yeah.
So 16 pi, with pi squared to the 4th,
8.
r to the 12th.
And then over 1/8 pi to the 6th, r to the 12th.
R to the 12th, so that makes us happy.
So then we're going to have 16 times 8, which is going to be 144. 128 pi squared.
Pi squared. So our 4-dimensional formula is going to be volume, surface volume to the 4th
Over hypervolume.
over hypervolume. I've got a cat going crazy in the background. Hypervolume cubed, and this is going to be 128 pi squared. So we're just going to have to take whatever this ratio is, divide it by 128,
And then square root the whole
and then
thing.
take the square root, and we'll have a good analogy in 4 dimensions for how hyperspherical some of these 4-dimensional shapes are. So here's our 5 cell, for example. Do you think this is going to be very hyperspherical?
No.
No, so you think we won't find a very good value for pi. What about our hypercube?
This still doesn't look very spherical, but I think it's more spherical than this. It has more edges.
Okay, so we'll start exploring that tomorrow. Okay?
Alright.
All right. Good job. Good work tonight, huh?